So, we're on the last lesson for grade 7, chapter 1, and this is on power patterns. Now, we looked before at some patterns with powers that we saw that something, for example, squared would always give the same last digit. So, for example, 1 squared is 1, and then 11 squared would give a final digit of 1. So 1, and then 11 squared is 121, and then 111, or even 21 squared, the last digit will be 1. In this case, it's 441. And then 31 squared, without even having to calculate, and I know the last digit will be 1. So there's a couple of patterns that exist within powers that are really cool. So, for example, 5 squared is 25. 15 squared is 225. So it ends with a 5, and it will always end in a 5 in that case. Some other powers don't really follow those rules. So, for example, powers of 2, powers of 3, powers of 4, they don't really follow those. But there are patterns for all of those too. So as long as you can notice that there sometimes can exist some patterns. So you could try it out, pause the video, try doing the square of 25, 35, even 45, see what the answers are, and see what any patterns you can find within the numbers that exist between those answers. So it's pretty cool. Take a look at that. Now, also looking at power patterns is combining powers and dividing powers, or predicting answers based on powers. So first off, we'll look at 5 to the 8th power. And what I want you to do is pause the video and expand that for me, so at least I know that you know what 5 to the 8th means. So after you expanded, you should have this answer: 5 times 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 5, which basically means 5 is the base, that is the number being multiplied, and 8 is the exponent, meaning that's how many times I will see the number 5 in this power. Now, this is pretty interesting, and I can predict again based on our power patterns that the last digit will be 5, because 5 times 5 will make 25, and then repeated after that, I'll always have a 5 as my last digit. But also, looking at how powers combine, well, we see 8 5s here. Well, let's see how that can be regrouped. So 5 to the 8, if I regroup this, let's say if I took these 4 and then these 4, well, 4 5s is really the same thing as 5 times 5 times 5 to 5 as 5 to the 4th power. And this is also 5 to the 4th power because it's 4 5s. The multiplication still stays the same, it's still in between. So look at this relationship, that 5 to the 8th is the same thing as 5 to the 4th times 5 to the 4th. We could also regroup the 5s in different ways. So if you wanted to pause the video and try to figure out, there are 3 other possible combinations, actually 4, but there's a lot of infinite possibilities, but there's a couple with positive exponents. Let's see if you can find out a couple of more. Well, if you regroup these, and maybe if you have 5 sets of 5, then I have 5 to the 5th, and I'll have 3 left over, so 5 to the 3rd. You could even try this out on your calculator. You could do 5 to the 4th times 5 to the 4th and see if you get the answer that would be with 5 to the 8th. I can also regroup this as 5 to the 6th, and I'd have 2 left, so that's 5 squared. And then the last example is 5 to the 7th, so I have 7 5s, and then I have 1 5 left over, which is 5 with 1 left over, or that's the same thing as 5 to the 7th times 5. So it's pretty neat how those combine if you look at how the relationship between the exponents and the actual answer that we're looking for. So here's another example. If I tell you 8 to the 12th is 68,719,476,736, I want you to predict what the answer to 8 to the 13th will be without using a calculator, and just showing me how is that related to 8 to the 12th. Well, we know that 8 to the 12th is 8 shown 12 times, and 8 to the 13 would mean another 8 added on or multiplied on to that 8 to the 12th. So remember, 8 to the 12th means these are 8s that are multiplied by itself, a total of 12 times that I see the number 8. A 13th 8 would basically mean that this is 60, well, this would mean that it is 8 to the 12th times another 8. Just like what we looked up here, that 8 to the 12th times another 8 gives 8 to the 13th. Well, calculation-wise, this is 68,719,476,736 times 8. Likewise, if I want to find out what 8 to the 11th is, well, 8 to the 11th means that I'm taking away one of the 8s that used to exist with 8 to the 12ths. The way that I can do that, to take away a power, is to find the opposite of multiplication. And the opposite of multiplication is division. So 8 to the 11th is really 8 to the 12th taking away or dividing away one of those 8s away from it. So if I take away one of those exponents, that means now I'm actually dividing by 8. Well, in this particular example, by 8. So that means 8 to the 11th will be this 68,719,476,736, all divided by 8. And that will give my answer for 8 to the 11th. So look at how these numbers relate. Look at how the exponent relates to the answer and to the base. See what stays the same and see what changes. We'll go over a couple problems in class, but that closes our chapter for number sense with exponents and roots and orders of operation and looking at power patterns. So hopefully you understand it, and we'll take a look at some more questions in class.